So we're supposed to consider a right triangle. So let's draw a right triangle with side A opposite angle A. So you can label it however you want since it's your drawing. Oops, sorry, capital letters are usually angles. So if you call this one capital A, this one's got to be lowercase a because that's what's opposite of it. If you call this angle capital B, this is lowercase b. And then we usually let letter C be the hypotenuse, the thing that's across from the right angle. So they tell us to find the lengths of the missing sides if sine of B equals 1/2. Now this part, this is where you might want to check out another video because this is kind of like a whole other topic in itself. We're asked to find exact answers. That means we can't use our calculator and make some sort of decimal approximation. Okay, so when you're trying to solve for an angle in a trig function, there's two approaches that are usually done. Teachers either make students memorize all the different angles, and like a teacher will give you a chart and it'll say sine of theta equals 1/2. That means theta is going to be, I don't have it through the memorization approach, so I just got to think it through real quick. 1/2 is opposite of 30, so this would be 30 degrees. Okay. So that's the memorization approach. Sine of theta equals the square root of 3/2. You would be asked to memorize that that is a 60-degree angle. There's a smaller memorization approach that I usually teach with students. I say think about a triangle, and just remember that it's a 30, 60, 90 triangle where the angles are 30 degrees, 60 degrees, 90 degrees. And what's opposite of 30 is always the 1/2 side length. What's opposite of 60 is always a square root of 3/2, and the hypotenuse is 1. So if you can memorize this triangle, it can help you find the exact values for trig functions. Okay. There's another triangle. There's a 45 triangle, but we're not going to get into that in this video. That's where you'd want to go. Search solving for exact values for trig functions. If you look that up on YouTube, if that's something you need extra practice with. That'd definitely be a good idea. So for this video, we're just going to focus on the 30-60 triangle. So let's see. So we're asked for sine of b equals 1/2. Remember, sine is opposite over hypotenuse. So when you look at this triangle, 1/2 is opposite of 30 degrees, right? So if we consider sine of this angle, it's opposite over hypotenuse. It makes a 1/2, just like it's supposed to over here. So in other words, b has to equal 30 degrees, so that sine of b is 1/2. Okay, so we know that capital B is 30 degrees. And then we can use that fact because if sine of b is 30 degrees, this has to be 60. Because it's a triangle, they all have to add up to 180 degrees. So now that we have that, let's see what other information we have. We're supposed to solve for B and C here. Sine of B is 1/2. A is 16. Okay, so we know A is 16. So we don't have to have the letter A here anymore. We know that this side length is going to be 16. So to find out B and C, we need to use right angle trigonometry. Okay, those definitions of sine, cosine, tangent. Like sine of an angle, so we'll call the angle theta, is the opposite of the angle divided by the hypotenuse of the triangle. Cosine of an angle is the adjacent to the angle over the hypotenuse of the triangle. And tangent, the definition of tangent theta, is it's the opposite of the angle divided by the adjacent of the angle. And so again, this is like this, the question we're working on, question 7, kind of assumes that you've already dealt with sine, cosine, tangent, that you know these definitions. So if you don't, we can talk about like an extra video to supplement that. But we need to use one of these trig functions to help us find a missing side. So let me clear the board here. Give us some more room to work. Okay. So you could look from the perspective of 30 degrees, or you could look from the perspective of 60 degrees. Either one you choose, it's not going to matter. You're still going to get to the right answer. Okay? So from 60 degrees perspective, let's just pick this one. We want to know either B or C. We want to put either one of those in our equation. So let's think about the sine ratio. So from 60 degrees perspective, sine of 60 equals the opposite side divided by the hypotenuse side. Right? 16 was the opposite side, so I put that in for O in the sine formula. And then the hypotenuse of the triangle is letter C. This is an equation that I can solve, right? Because this is just a value. We're going to actually figure out what this is using the special triangle again. This is a value. This is a variable. So now we just have an equation with one variable we can solve. So to figure out what sine of 60 degrees is using exact answers, we got to go back to the special triangle that we've used already. 60 degrees. From 60, if we're trying to find the sine ratio for 60 degrees, the square root of 3 over 2 is the opposite, and the hypotenuse is 1. So the opposite over the hypotenuse is square root of 3 over 2 divided by 1, or in other words, it's just square root of 3 over 2. The exact value for sine of 60 is square root of 3 over 2. And if you really have trouble with that, I think you could probably get by in this course if you just search for exact values for trig functions. You'll see a table come up, and it'll say sine 60 is square root of 3 over 2. It'll say sine 30 is 1/2. Sine 45 square root of 2 over 2. It'll have all those variables. Okay, and then to solve this equation for C, there's a couple of different ways of doing it. You can multiply C to both sides. I think the easiest way to do it is to do the cross multiply and divide trick. If you multiply across the diagonals, like square root of 3 times C equals square root of 3C, and then 2 times 16, that makes 32. Okay, you can do that when you have two fractions set equal to each other. And then to finish getting C by itself, we just divide both sides by the square root of 3 over. So you get C equals 32 divided by the square root of 3. So we've got one of the missing sides. Okay, we know that the exact value for C is 32 over the square root of 3. Okay, to find out the other one, we could use right angle trig again. I think it's actually going to be easier though. I don't know. Let's do right angle trig one last time. You could use the Pythagorean theorem from here, right? A squared plus b squared equals our new c squared that we just found. You could use the Pythagorean theorem, but let's go ahead and use right angle trig one last time to practice that. So we want to know what this b is. Okay. We want to know what side b is. So in order to get side b, if we're going to use the right angle trig approach, look from 60 degrees perspective again. We can't use sine because that would be the opposite divided by the hypotenuse. That doesn't involve b at all. So looking from 60 degrees perspective, we could use cosine, because if this is the opposite and if this is the hypotenuse for 60 degrees, then this has to be the adjacent. So cosine of 60 is the adjacent side divided by the hypotenuse, which is 32 over the square root of 3. Or you could even set up a tangent ratio. If we're looking from 60 degrees perspective, tangent of 60 would be the opposite of 60 divided by the hypotenuse. Divided by the adjacent. I said that wrong. Tangent is opposite divided by the adjacent. So it's 16 divided by b. And so that's this one's a little bit easier to work with because we don't have square roots. So let's take tangent 60 and find out the exact value for this answer. So tangent 60 is going to be the opposite over the adjacent. So if we go down to this triangle that we said we could memorize that would help us through all these problems, look at 60 degrees. What's opposite of 60 is square root of 3 over 2. And what's adjacent to 60, like this is the hypotenuse, this is the opposite, so this has to be the adjacent. So we need to take the opposite and divide it by the adjacent, just like the tangent formula says for us to do. Opposite divided by adjacent. So if you do that, you're going to flip and multiply the second fraction. And so this is the value you'd get if you search for exact values for trig functions. Tangent of 60, the exact value is square root of 3. So basically what we found out in this equation up here that we're trying to solve, square root of 3 goes on the left side. clear this. Alright, let me just copy it over here. Square root of 3 equals 16 over b. So in order to get b by itself, we can multiply both sides by b. So we get square root of 3b equals 16. Then to finish getting b by itself, that's square root of 3 times b. So we're going to divide both sides by the square root of 3. So there's our exact answer for b. So when you type both these in, use parentheses to protect the numerator. Then divide by the denominator. And I'm going to actually give myself some space just so we can zoom in, can't I? So in the denominator I'm going to type SQRT, that's Mobius's way of doing square roots. So there's our b, and then for c, when we type that in, I forgot what we had for c, 32 over the square root of 3. So my numerator, divide by my denominator, and I need square root of 3 again for the denominator. Okay, so that's how you can type it in, and then Mobius will accept that. Okay, there's other ways of rewriting these same answers, but Mobius does accept these. You could do something called rationalize the denominator, but if we're having trouble with the trig part, it's probably best that we don't even talk about rationalizing the denominator yet. It just is a way of rewriting the answer, so it's equivalent, just in kind of a neater form.